Welcome back. In the previous video, we looked at how we can reduce an aldehyde and a ketone. Now, if you see that a couple of reagents stayed in this one as well, but you see they're written differently. Now, typically in an organic reaction, what is written on the top is what's reacting first with the substrate. What's written below the arrow is what's returning second. So, speaking from that perspective, your HCN is what's first reacting with your aldehyde or ketone, and then the second reactant, which is below the arrow, reacts with that product from the first step. Okay, now let's take some introductory knowledge on CN. Okay, CN is nothing but cyanide. Okay, when CN is in its negative form, in its ionic state, it's called cyanide. Okay. All right. Now, HCN is hydrogen cyanide. Okay, it's just the way it's written, hydrogen cyanide. Now, CN minus is a strong base. Okay, moderately strong base, and when it's reacting with a carbonyl, such as an aldehyde or a ketone, it produces different products, and that's what we're going to look at here. Now, I'm only going to explain the mechanism for the aldehyde because the mechanism itself is the same, whether it's an aldehyde or a ketone. This is an aldehyde, and this is a ketone, right? Okay, the mechanism is the same, and because of space constraint and time constraints, I'm only going to explain the mechanism for one, and the mechanism is the same for the other. All right, so let's first react with the HCN. Now, HCN, as I written, is H plus and CN minus. The CN minus is what is used to attack the carbonyl, and then the H plus joins the body. So let's look at the actual mechanism. Okay. Let me get a different color. Okay. So first it's the CN minus that attacks this, and whenever a negative charge attacks a carbon containing a double bond O, the bond breaks and comes back to the oxygen, which in turn results in, I'm going to write it exactly everything the same way, but get my purple this time and write what has just happened. You've attached the CN to this carbon through the negative charge, and then the oxygen now gets the negative charge. So something has to take the negative charge, and it's the oxygen. Now the H plus obviously reacts with the negative charge, and it gives you your product. Let me write it in a different color. This is the step of the first. This is the product of the first step. Okay, this is not the final product. Okay, so you get CN, right? Now, if you notice something right away, when reduced, an aldehyde produces a secondary alcohol. This is an alcohol, right? Because the carbon containing the OH also contains only one hydrogen. It's 1 degree, right? So it's a secondary alcohol, right? So when aldehyde reduced produces a secondary alcohol. Now, this is not the end of it. This is the first part of the reaction, right? We still have to use this. So this is going to be constant whether you're starting with an aldehyde or ketone. This step is exactly the same. Lithium aluminum hydride, THF, and water. What it's going to do is the CN, okay, when reduced, always going to produce this as a byproduct, and it's attached to the ring or the straight chain through the CH2. Okay, this doesn't change. This is a constant. So what is going to happen now here is I'm going to draw everything in black, just like the way it's appearing above, minus the CN, and I'm going to write that in a different color. Now, the reason I'm writing in a different color is that part is constant as long as this reagent is LiAlH4. As I said, you replace the CN with CH2 and H2. Okay, this is what is the actual final product. If you notice, still the secondary alcohol is retained. It's not disturbed once it's formed. So when an aldehyde is reduced, it produces a secondary alcohol. Now you could guess, or actually without going into the mechanism, you can figure out the product. So let me write the product. If you're curious, which you should be able to go figure out the product for this reaction involving a ketone. As I said, everything is exactly the same, particularly the second part is always going to be the same. Whenever you reduce a CN, it produces CH2 and H2, and this is what we mean by reduced, is these are your reducing agents. So if you apply everything into this problem, which is a ketone, this is what you should get as a product. I highly recommend, why don't you pause the video now and figure out the product and continue playing to see if what you have and what I have written for product is exactly the same thing. If not, well, you have to try again. Okay? All right, so this is what you should have got if you had done your mechanisms right. If you notice, if you start with aldehyde, you end with a secondary alcohol, right? A carbon containing the OH contains one hydrogen. Whereas if you start with a ketone, you end with a tertiary alcohol because the carbon containing the OH contains no hydrogens, right? So that's very, very important to remember that. Okay? So let's take this all in perspective. So when you reduce, if you're starting with an aldehyde, you produce a secondary alcohol. If you just stop, this could be a mechanism on its own, the first step. I'm combining two reactions to see how you can also have alcohol, you can also have an amine, okay? And then if you start with a ketone, you end up with a tertiary alcohol. Now, NH2 is an amine, right? So if you remember I will come back and discuss more about amine because those are my next two reactions on the list, all right? So this is how you reduce in an aldehyde or ketone in the presence of HCN and lithium aluminum hydride, all right? So stay tuned for a couple more of reactions.